Hi everyone, in this video I will walk you through the MATLAB and Simulink environment, what the different parts of the screen are, where to find things, and how to set everything up correctly. This video is a reference. If you are already comfortable navigating both tools, feel free to skip this and come back whenever you need a reminder. So MATLAB is a programming and numerical computing environment. You can think of it as a very powerful calculator that also lets you write scripts and functions. You define variables, run equations, plot results, and organize your code into files. For our purposes, MATLAB does two important things. It is where we define all our model parameters before simulation, and it is the engine that Simulink runs on top of. You cannot run Simulink without MATLAB. Before starting in MATLAB, it's best practice to create a dedicated workspace. To keep our data organized and professional, we will start by right-clicking the desktop, selecting New, and then Folder. Name this folder MATLAB. You can name it anything based on your project name. Having a specific directory ensures all scripts and variables are saved in one reliable location, making your workflow much more efficient. Now we are ready to begin. When you open MATLAB, you see three main areas. On the left is the course folder panel. This shows all the files in the whatever folder you are currently working in. In the center is the command window. This is where you type commands directly and see results immediately. On the right is the workspace. This shows every variable that is currently loaded into memory, its name, its value. Now we will make the MATLAB folder which we created on the desktop as our current working directory. To do this, click the Browse for Folder icon next to the address bar. Navigate to your desktop and select the MATLAB folder which we just created. If your files are not in the current folder, MATLAB will not find them when your model tries to run. This is one of the most common beginner mistakes, so make it a habit to check this first. Now let's look at defining variables in the command window. We will start by defining a is equal to 1 and b is equal to 2. Notice that without a semicolon, MATLAB immediately repeats the value back to us. To keep our workspace clean, we can use the clear all command to remove variables from the workspace and CLC to clear the command window entirely. As a professional habit, always end your statement with a semicolon. As you can see, when I redefine the variables with a semicolon now, the values are stored in the workspace but don't clutter the command window. This is essential for keeping your work organized as your code becomes more complex. While the command window is great for quick tests, the professional way to work in MATLAB is by using .m files. A .m file is essentially a script that saves your code so you can run, edit, and share it later. To create one, right-click inside your current folder window, select New, and then choose Script. Let's rename this file to test1. Now consider the editor. We will define our variables. A is equal to 1, b is equal to 2, making sure to use semicolons to keep the output clean. When we click the Run button at the top, you will notice two things. The script name appears in the command window to show it executed, and our variables immediately pop out in the workspace. Using .m files is a more efficient and organized way to build your projects, ensuring your work is saved and reproducible every time. Before we dive into Simulink, let me explain what a Simulink is. Simulink is a powerful tool made by MathWorks for simulating and designing dynamic systems. It works with MATLAB and lets you build models using block diagrams instead of writing code. You simply drag and connect blocks on the screen to create and test your system. This makes complex engineering projects much easier to understand and manage. To open Simulink, click on the Simulink tab in the top menu. A new window will appear with different options for creating or opening models. Click on Blank Model to open a new empty Simulink model. After a few seconds, the Simulink window will open. The main area of the Simulink window is the canvas where you drag and drop blocks to build your model. Before starting any new project, create a new Simulink model in your desired folder and give it a proper name. The library browser is one of the most important parts of Simulink. It contains all the available blocks. When you click on the library browser, all the available blocks will be open on the left side of the window. To add a block from the library browser, for example a constant block, simply type the block name constant in the search box at the top of the library browser. Once the block appears, you can drag and drop it onto the main canvas. You can do the same by clicking on the Simulink within the library browser, then click on Commonly Used Blocks. Here you can drag and drop the same block to the main canvas. Alternatively, you can double-click anywhere on the blank canvas in the Simulink model window. A quick search box will appear. Type the name of the block, for example, constant, and the blocks related to that name will appear. Simply double-click on the desired block and it will be added to your model. In MATLAB Simulink, the timing settings determine how the model progresses through time, how accurately it captures system dynamics, and whether the results match the behavior of real digital controllers. If timing is set incorrectly, you can get unstable or unrealistic responses, choppy or discontinuous signals, controllers that behave differently from hardware, and extremely slow simulations. This is why timing is not optional, it is a core part of building reliable engineering models. In order to set up the simulation timing, go to the Modeling tab. Here click on the downward arrow next to the Model Settings. Here choose the Model Settings menu. After a few seconds, a new window will open. The solver panel is the most important. First set your stop time, which is how many seconds the simulation runs for. Here it's showing 10 seconds at the moment. We will reduce it to 5 seconds. You can increase or decrease the stop time based on the simulation conditions. Second, choose your solver type. For most control and motor simulations, use fixed step. This gives you consistent, predictable timing, which is important when you are modeling digital controllers. For the solver algorithm, ODE3 or ODE4 are good general choices. For the step size, start with 1 exponent 1 e raised to the power minus 4, that is 0.1 milliseconds. You can set it by clicking on the solver details, and here you can set the fixed step size to 1 exponent minus 4, which gives good accuracy for the system we will build. If your simulation is very slow, you can increase this slightly. If the results look wrong or choppy, reduce it. Then click Apply. So in this session, we learned the essential basics of MATLAB and Simulink. We started by creating an organized workspace, explored the MATLAB interface, and understood how to define variables and work efficiently using the script.m files. We then moved to Simulink, where we discovered how to open models and easily add blocks using the library browser or quick search. These foundational skills will help you build, simulate, and manage engineering projects more efficiently.